Alright guys, let's see my actual test setup for the equalizer module, and here it is. It is sleeping now. So I have here the music source, which is from my mobile phone, and I connected the music source to the DAC. This is DAC FX06, and then the output is connected to the EQ module. I tap it into the input of the EQ IC, which is in here, and then it is processed in the EQ IC, and the output is here. This is the output, and then it is driving a headphone. Yes, the EQ IC maximum bauded swing at an input of sine wave 1 kHz is 2.3 volt RMS, so that is enough to drive a headphone right now, because this is the economical way and I would say effective way to test the functional of the EQ. And I don't have the big amplifier right now, but definitely if you have the amplifier, then you can use it. For my case right now, I just using the headphone, and well, it can work. This is my power supply, which is set at 12 volts, and the current that is being drawn from this power supply is 17 milliamperes. 17 milliamperes when the EQ module is sleeping. That means it is in the standby mode. Currently the EQ module is not interfaced to the microcontroller, so I just have to simulate the logic input control to the EQ module, which is I just label them here as a EQ. TB means turbo bass, EQ is the equalizer mood select, and the 3D sound. And also for the power supply control, we have the EQ standby here, and this wire here is a digital ground. Now that should be the analog ground. It is labeled as a GNDA. Well guys, take note that you can see that this is a red color wires, and it is labeled as a analog ground. I mean that should be black if we're going to follow the color coded for wires, but unfortunately there are wires that is not standard, and we just cannot rely on the color. So the correct one should be this wire should be the GNDA, or the analog ground. Unfortunately they were exchanged. Well, anyway, I remember the first time that we have a sample for the wires. This wire should be I mean this GNDA wires, the color is black, and the B plus is red, and this one is yellow. So they were interchanged, but we cannot get those wires anymore, because the sample that procured by Anna Chan is a different color combination. So we just have to label them correctly, and for a moment forget about the color coded for the wire, which is the red should be the power supply, and the black should be the GND. Just take note of that. As you can see that the controls for the EQ IC solution, which is the level converter, the schematic is here. This part should be controlled by the microcontroller, but at this moment I don't have yet the control module to control the EQ. So what I did is that I just have to simulate the logic level. So like for example, we have here at the GND is again a red color, and this one is the 3D sound. So they were tied together. So the logic level initially of the 3D sound is at logic 0, which is means to say that this 3D sound here is connected to G and D, so that these transistors here is not active. So this transistor is not active and this transistor is not active as well. So that means to say that the 3D sound is off. Right, and also for the turbo bus and the turbo bus here, and then the EQ selection mode, they were tied to here. They were tied at the B plus. So the initial state of the controlling logic is logic 1. That means say that the equalizer mode and the turbo bus control is pulled up to logic 1. Alright, let's power on. What I have to do is that the EQ standby mode, I need to remove it from the B plus. So currently now, if we put the controlling logic or the power supply to logic 1, then the system is in the standby mode. So let me pull that out here, manually remove the wire. There you are. You got the power there, and the current drawn from the power supply become 27 milliamperes. So okay, the initial wake up mode of the equalizer is the left or the rightmost LED. That is the normal. So let's play an MTV video by Tiffany Alvord, Listen to Your Heart. It's a soft music, and I would love to hear the soft music because it's something that I like to hear while testing, and I'm very familiar with the song. Listen to Your Heart. I have to get my headphone first. Okay, hang on, sorry for that. And yes, I can hear the music, but you cannot hear it because of the I'm just using the headphone. Alright, so I'm going to remove the headphone, and I'm going to change the headphone with this PC speaker. Now you get the music. Increase a bit. Listen to your heart. You can see the EQ is turned on here. So if I'm going to simulate the logic here by removing the EQ mode from the logic 1 or from the supply, the next is rack. So let's see.
Sometimes you wonder if this fight is worthwhile. The precious moments are all lost in the time. Yeah, they're swept away. Nothing is what it seems. The feeling of belonging to your dream. Listen to your heart when he's calling for you. Listen to your heart.
That is the EQ, and I can also do that to the turbo bus control. So I need to tie the control of the EQ to the logic 1 ops. That's not a good connection. I have to tie it. Alright, there, and I need to remove this action. So let me reposition the camera. This LED here, the first yellow one, is the indicator for the turbo bus on and off. So What I have to do again is to just momentarily connect this control pin. This is the control pin for the turbo bus, and momentarily connect to the B plus, which is simulating a logic 1. So okay, like that. Okay, so let's hear the music.
Listen to your heart. I know there's something in the wake of your smile. I get an emotion.
So I just have to momentarily connect this, and the LED will turn on and turn off, so as well as the 3D effect will turn on and turn off. Let's see that. There you are. Okay, let's hear the music.
Listen to your heart. I know there's something in the wake of your smile.
Okay guys, that's the end of the test. It was a successful test. Me in here being the tester and observer, I can feel and hear the difference of the mood from normal to rock, to classic, to pops, to jazz, and I can also hear the difference when I turn on the effects, the 3D effects, on and off. But it's quite difficult to hear the difference when I turn on the turbo bus, perhaps because of the type of music and the kind of speaker that I'm using here. It's a small PC speaker. But then I'm going to recheck that with the bigger speaker. So the next thing that I have to do now is to populate the DGTC solutions in here. And then I'm going to do the same test again with the addition of volume control. That should be the TR 100 watt control module should be interfaced to the EQ module, because the DGTC will not operate without the I2C protocol, which is I cannot do that simulation manually. The only thing I have to do is that I need to make use of the control module, which is the other being tested. And basically we can see what's the time now. It's 7:33 in the morning. So this is the time, this is the hour, and this is the minute, and 7:33 in the morning. Well guys, I used to work in the morning because this is the only time that my son or my family is still sleeping, and normally I started to work at like 4 o'clock in the morning, early morning, because somehow I need to work, I need to go to my job site before 9 o'clock in the morning. So this is the only time that I have time to do my electronic stuff at home. Let me show you the original one. I'm trying to reach the okay, it's a lot of so basically this is the first prototype design in LSPD1, the circuit design. You can take a look at it. This is the first prototype by the team, prototype by Ariel and me, and you can see first integration of the EQ module and the control module. So stay tuned, and again, thank you for watching.